So notice here on number 2 that these two fractions already have the same denominator. That's nice. On Monday, it won't be nice. They'll have different denominators. That's why 7-4 is the hardest section. So, yeah, these are nice. You know when you have, just think about numbers for a second. Like, what if you had 7/10 minus 3/10? What would you do? Would you go 7 minus 3 is 4 and 10 minus 10 is 0? No, you wouldn't do that. What would you do? You would just leave it 10, huh? Yeah, it's just, no, why? Why? Because math teachers say so, and we rule the rule. No, that's a dumb reason. Because it's true, right? Just think about a pie or anything in the real world you want to think about. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's a pie. That's the best drawing I can do in that period of time. There's 10 pieces. 10 pieces of pie, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if I said, there were 7 pieces left. So 4, 5, 6, 7 pieces left. And somebody ate 3 of them, subtracted 3 of them. They took off these 3. What's left? How much of the pie? 4/10. It's the truth. That's why we leave the 10 on the bottom, because it's true. That's always the reason for math. Now, one more thing. We don't leave 4/10 like that. What do we do with it? We divide it. We simplify it, right? So it'd be 2/5 in the end, which is the same thing. 4 out of 10 is 2 out of 5. So there we go. So you get the game plan, right? If they already have the same denominator, just leave the denominator, subtract the top, simplify at the end. That's for simple numbers. It's the same thing for x's. So try that one. So keep the common denominator. Do the same thing with the letters we just did with the numbers. So they already have the same denominator, don't they? So I will keep the common denominator. Don't need to mess with that at all, just like back over here, right? I just kept the 10 as 10. I mean, I might do something later, but at first, with the subtraction, just keep it 10. So keep it m minus 8. And then on the top, just 6m minus 48. Good so far. Nothing too fancy there. Now, right, just like what I did here, just 7 minus 3 made 4. But then what did I have to do at the end? Simplify. So how can I simplify? I've got a plan. You can tell by my tone it's a crazy plan. I'll just cancel out these m's.
No.
What's wrong with that? They're glued packages, aren't they? Right? So no. They're buy the whole package or buy nothing. Don't buy part of the package. So we can't do that. So then what do? Factor. That's why we spent that whole chapter factoring. Because factoring is in everything now. Take the GCF out of the top. So the subtraction thing is over. Now it's just a simplify problem. Take the GCF out of the top. Oh, they're not giving us the answers anymore. So on the test, I'll give you the answers. It's just I'll give you 4 false ones also. All right. Sorry. It's not funny to joke about math tests, is it? Okay. So how do we, what's the GCF on the top? Take out a 6. M minus 8, huh? Because that would multiply to go back. And so then now we can buy the whole package. What's the answer? It's just 6. That means all of this is a fancy way to say 6. We good? All right, let's keep moving. On to number 3 we go. All right, this one's a little more tricky. It's got a common denominator. I'm going to let you do it wrong at first, and then I'll correct you. I'm assuming the majority of most people, first time, do this problem, the very first step, wrong. Be careful on that first step. I think you'll get more out of it if I let you do it wrong and then I correct you than if I just said it. Common denominator. We don't need to mess with the bottom, right? Just common denominator. The top we're going to subtract. Okay, and so, did you do the rest? So here comes the part that gets people. I'm supposed to subtract. What am I supposed to subtract? All of this, not just the front part. The common mistake is people go minus 11x plus 3. Wrong. What's wrong with that? Yeah, that minus needs to go also to the 3. The minus needs to, you're subtracting the whole right side, not just the front part. Right? Everybody see that? That minus needs to go to everybody. Super common mistake in algebra. Y'all see that? You can't just put that minus on the front one and not let it hit the back one. You're subtracting the whole 11x plus 3, right? The whole fraction on the right. Not just the front part. So now it's good. Take it from there now. Gather like terms. Can you gather like terms up here? All right, make that minus 2x in the middle now. And then
you divide in 2.
Do what? Factor.
So now it's going to be, you need to factor minus 11x minus 3.
Yeah, but 9x and 11x. No, because they're two separate equations.
So it'll be 5x squared minus 2x minus 3. So far, so good.
Because 11 minus 9, right?
And now we need 9 minus 11. And now we need to factor that numerator. And that's the harder kind of factoring. Do you see that? Because of the number in the front. FOIL. That's harder. And I don't have a lot of time to do it slowly. So I'm going to do it quick. What times what is 5x squared? 5x and regular x. But now the order matters for the back two because we have different fronts. It's not just x and x. It's 5x and x. So what multiplies to be 3? 1 times 3, but only one order works. It's this order. 3 here, 1 there. Sign. Now, you should do the inner arcs is 3x. The outer is 5x. How are they going to make the middle of minus 2? Sign in the middle. Sign on the bigger, minus 5 plus 3. So the plus goes on the 3, the minus there. Sorry, I got to keep moving, but we've been over that section. So I hope you're getting comfortable with those harder FOIL factorings. So now the x minus 1s cancel. And so what are we left with? Just 5x plus 3. That's it. There's no more denominator at all. 5x plus 3. Is that good? Questions on that? Okay, so I'm going to move on. When you subtract, this minus is going to go there and there, isn't it? It distributes is really what it does because you're subtracting the whole fraction on the right. So it goes to both of them. So what do we get? So the denominator doesn't change. It's common denominator. We good to there. So then combine like terms up there. Right? It's going to be x plus 4 on the top. And then you got to factor that bottom. And I'm betting one of the terms is going to be x plus 4 on the bottom. Have you seen how they write these things? They're pretty predictable. If you got an x plus 4 on the top, I bet one of those two parentheses on the bottom is going to be x plus 4. We know that.
X here,
And then you go in the right direction.
and the front is plus. It's minus of x plus 4, so this is 5 and 4.
This is good. 2x minus x is x. Plus 1 plus 3 is plus 4. Good so far. Just combine like terms. Now on the bottom, this is FOIL factoring, isn't it? FOIL. But it's the easy kind, with just regular x squared in front. Just x is in the front, huh? That's the easier kind. What multiplies to be 20? What times what is 20?
5 times 4.
5 times 4. Either order doesn't matter because there's just plain x's in the front. They're the same fronts. So it doesn't matter which one you put it in. Now how do the signs go? Sign in the middle goes to the bigger. No surprise, there's an x plus 4. These guys are so predictable to write these questions, right? Getting the hang of this?
It's x minus 5, but you need to put 1 on top or just leave it x minus 5?
Oh yeah, good question. So these will cancel. Yeah, good question, Manuel. Yeah, good question. I'm glad you brought that up. Yeah, a lot of times over the years, I'll see people do fabulous work all the way to here, cancel that out and go, all right, I got it. The answer is x minus 5. No, that'd be a bummer. That'd be like intercepting the football and running it back and tripping at the end zone.
You need to put 1 on top.
Right, you're right there on the verge of the right answer and you fumbled again. Well, why is that wrong? What's wrong with that?
It's underneath.
Yeah, if I just write x minus 5 all by itself, it means over 1. And that's not the right meaning. It was never in the top. So how do you keep it in the bottom? You put it under 1. That's correct, huh? Does that make sense? When the whole top vanishes, that does leave a 1. Right? That's not new. That's not something new. You know that already. Think about 2 over 6. What is 2/6 the same as? 2 goes into 6 3 times, and what do? Say blank over 3?
Once you get this one on top,
You say 1/3, huh? You know that. That's just dividing by 2. I'm really just dividing by 2. 2 divided by 2 is 1, huh? So that's what happens. That's what's always happened with fractions, right? When the top vanishes, it leaves a 1. Question? Mackenzie?
Okay, maybe I missed it, I don't know. How did you get the blue x plus 4?
Combined like terms. So 2x minus 1x right up here. So 2x minus 1x made 1x. And plus 1 plus 3 made plus 4. Just combine like terms up there. Is that okay? Does that make sense? Other questions on that one? All right. It'll be on YouTube. Let's keep moving. 6, LCD. They're asking us what's the common. They don't even care about the tops. Just blah, whatever. We're not even thinking about the numerators at all on this problem. All we're looking at is the 2 denominators, and we're saying, what's the LCD, the common denominator? Let me give you the simple rule, and then we'll do our best to follow it on 3 or 4 examples, and we'll be out of time. LCD, take one of each type, well, each letter or parentheses letter package. So take one of each letter or parentheses letter package to the highest power shown. That's it. Oh, that's not it, actually. That's the LCD for letters. That's how you do the letter part of the LCD. And the LCD for numbers is you take the number that they all divide into evenly. You actually take the lowest number, I should say. You take the lowest number that they all divide into evenly. That's why it's called LCD, lowest common denominator.
The numbers.
So we have one thing we do for the numbers and one thing we do for the letters to find an LCD. So I'm going to look at this. Hey, this 6, is he glued to that x plus 4? Are they a package deal? No, that's Save Mart. There's no plus sign in there. So I'm going to think about that 6 separately. If that was 6 plus x to the 4th, I would not be thinking about that 6 separately. I would be saying he's a package deal. That's what I'm talking about over here. That's something else, right? This one is not packages, is it? That 6 is separate from that x to the 4th. That 3 is separate from that x squared. No packaging. This is not Costco on number 6. This is Save Mart, right? Okay. So I'm thinking about the 6 separately and the 3 separately because they are separate. Okay, when it comes to 6 and 3, what number do 6 and 3 both go into?
3.
No. What?
18.
What? No, 6 doesn't go into 3, does it? 6 is the answer. 6 and 3 both go into 6. Now you might say, well, 12, don't they go into, they do go into 12, but I want the lowest number they both go evenly into. 6 is the lowest number that 6 and 3 both go into evenly, isn't it? 6 is the smallest number. You with me on that? Right? 6 goes into 6 and 3 goes into 6 evenly, don't they? That's the lowest number they both go into. So 6 is the number part of the LCD. It's the lowest number they both go evenly into. Okay, and now the letters are easier. What do you do for the letters? You just take each type to the highest power. So it's kind of like you're shopping. What if you said, hey, I'm going to go on a shopping spree. I'm going to go to the store, and I'm going to buy one of everything. And I'm going to buy the most expensive version of everything. So I'm going to buy one bottle of shampoo, the most expensive one I can find. And I'm going to buy one, lawnmower, the most expensive one I can find. That's what we're doing with the LCD. You're going to buy one of every type, the highest one. So I look and I go, okay, x to the 4th, x squared. I'm not going to take them both. Just one, the higher one. X to the 4th, done. Does that make sense what I'm saying? So when it comes to the letters, you only take one of each letter or letter package. I don't take the x to the 4th and the x squared. I just take one of them to the highest power shown. I took the higher power one, not the lower one. Questions?
Why did you cross out the tops?
Because this has nothing to do with the tops. They're asking me about the common term. I'm not canceling the tops or anything. I'm just saying, don't even look at the tops.
So why are they there then?
There are fractions. But what they're doing is they're warming us up for next time when we will have to deal with the tops and everything.
I like if I just look at it, I'm gonna be like, okay, what do I do with this?
Yeah, so on this one, it's just a question. Notice the question. Find the LCD. So it's just denominator. It's only a question. They're just warming us up. Next week, we'll do the whole thing.
Exactly the same.
Is that good? You understand the shopping thing? Oh, that took some time, huh? So if I said, hey, 3 and 6 both go evenly into what numbers? What bigger number can absorb them? 6 can, 12 can, 18 can, 24 can. These are all the numbers that can absorb 3 and 6, that 3 and 6 fit into evenly, could divide into evenly. So among those, who's the lowest? 6. So these are all the common denominators. And who's the lowest among the common denominators? 6. So you're listing all the numbers they go into, taking the lowest. All right. So we just got moments left. Let me do this with you quickly. So what am I going to do with the tops? 18 and 17. Nothing for now. Next week, we'll deal with the whole thing. For now, they just want to make sure we're good with the common denominator. So what is the common denominator? Am I going to think about this 3 separately? No, it's a package deal. It's glued. This is Costco on this one, right? These are glued together. So I'm not thinking about that 3 separate. This is a package deal, huh? So what do you do when you're shopping at Costco? So we're going to go shopping. Those are letter packages. So I have no independent numbers in this problem, do I? Remember I told you how to do the LCD for independent numbers. and how to do the LCD for letter or letter packages. All I've got on this one is letter packages. I don't have any independent numbers. So I'm just going to do the shopping thing. What do? What's the shopping plan? One of each. Throw it in your cart. Throw in the x plus 3. Throw in the x minus 3. Done. One of every type. Those are different package types. They're similar, but still different. Make sense? Yeah.
So if I was at x squared minus 9, would that work as well?
They might take it that way.
And then you need to put a comma.
They might, because that is x squared minus 9. You're right. If you foil that, that'd be x squared minus 9. So I think they'd probably be good with that. Yeah, it is the same thing. Let's do number 8. Yeah?
You need to put a comma between those two, no?
Nope, no comma. I don't think so. Nope. Number 8. So number 8, first we have to factor this one. Whoop, what did I just hit? A crazy button there. There we go. See how this one needs to be factored? Factoring is everywhere. That's why you've got to master that last chapter or do something else this semester. Seriously, I'm not trying to be mean. I'm trying to speak truth to you, right? If you don't master factoring, ball game is over, right? The rest of this ball game, we got to factor everything we do. You got to master chapter 6. So, how do you factor this? What do you do? Take out the GCF. X minus 4. Good. All right, now let's form the LCD. So what do we do for the LCD? What's the game plan? First off, do we have any independent numbers?
28.
Independent numbers. Only this 7. This 4 is glued. He's not independent. Right? This guy's gone. He's been replaced by the factored version. You with me? The only non-glued number is the 7. Right? He's the only one that's an alone, separate, non-glued number. So, all right. So we need him. He's the only number. So he's the number part of the LCD. Now it's time for the letter packages. Let's shop the letter packages. So we're at Costco, we're shopping. What's our game plan? Buy one of everything, the most expensive version. The most expensive version. So I'm going to go and okay, I've got an x minus 4 squared, and I got an x minus 4. Are they the same thing? Yep. So which one am I going to take? The squared. There it is. So we're not adding them up. I didn't take 3. You with me? I didn't say, 2 and 1 is 3. We're not totaling. I'm not buying all the lawnmowers at Costco. I'm just buying the most expensive one. Right? See that game plan? All right, we're out of time. We're overtime, aren't we? That's all we can do. You two.